Hello, and welcome back to episode 5 of Penrose from Scratch. This time we're going to be having a look at something called state extensions. The types that you're going to see here, the function signatures are going to be potentially a little bit confusing if you've not done much Rust programming before. We're going to be using things like arcs and ref cells, and we'll be kind of having to do our own kind of state management kind of stuff. But so long as you kind of follow along with what we're doing today, it's not actually that bad in practice. Just if you start making some mistakes with anything or have any compiler errors, they might look a bit funky compared to what you'd normally see. But as long as you follow a couple of simple rules on how to use this stuff, it's all going to be fine. So we'll have a look. The idea behind this is to add your own extra state into the window manager. So in addition to all the kind of stuff that we have around where your windows are, what your workspaces are, what screens are currently attached, how big everything is in terms of like geometry and rectangles, you might want to track some more things. So the most obvious kind of place that this gets made use of is the status bar down here. So we're tracking which workspace is active, we know which layout we're using, all that kind of stuff. Like if you add widgets in, those widgets need to exist somewhere so that you can render them out, and they also need to know what text they're displaying. So that is handled as this kind of state extension idea. So we'll have a look at the status bar towards the end of this, I think. But the status bar's got a lot going on compared to some of the simpler stuff we can have a look at. So we'll kind of build up to that. There's another thing that uses state extensions that kind of comes from Penrose, which I think we'll set up as well, which is named scratchpads. So that just lets you have a little kind of pop-up terminal window. It's the way I use it, but you can put any program you want in there. You could have kind of, I think I've done one for like a Python interpreter before, like IPython. You could have a web browser. You can kind of have whatever you want, really. But they too kind of use this idea of like storing some extra state that you need to get back at. So we'll have a look at how this all works. I think we'll do this as a little bit of like a code example that's separate from the window manager. We'll kind of just write some code with a dummy window manager that sort of shows how the state extension stuff works, rather than try to sort of iterate on the window manager itself, because it's probably going to be a little bit easier that way. So yeah, let's dive into it. Let's crack in. So the first thing that you need to know is, as you might expect, if it's a state extension, that's going to be something involving the state struct. And you'll see that there is this method on the state struct. If you go to the docs, link will be in the description down below. It's just called extension, and it's got this rather odd-looking type signature. It says that it is generic over E, which is any, which is, as it sounds, it's literally any type you want. And you'll get back a result, this thing, arc ref cell E. Now, I'll include some links to the docs on arc and ref cell down below. If you want to know how this stuff works, or if you already know how this works, then you're probably thinking ahead and you can see why this is set up the way it is. But an arc is a way of kind of doing what's called reference counting. So rather than the normal kind of borrowing and sort of reference kind of rules in Rust, where only one thing can have mutable access at a time, an arc is a way of sharing access to stuff around across threads and just sort of making things a little bit easier to work with. Not even easier to work with. You need to do it in a lot of places if you're using kind of threads and various bits and pieces. And then a ref cell lets you do sort of runtime borrow checking. That's probably the best way of putting it. So you're probably familiar with the borrow checker for Rust if you've learned anything about Rust. And that's sort of at compile time, the Rust compiler making sure that you are you're not going to have kind of data races. You're not going to have multiple things trying to modify a value out from underneath each other. A ref cell is runtime checked. So there's a little bit of a performance hit, not massive, but it's not as, it does need to do some runtime checks to make sure that modifying the data is safe. But it allows you to avoid a bunch of kind of lifetime issues, so you don't get those horrifying kind of issues in your code where the borrow checker screamed at you. That kind of combination of an arc ref cell or an RC is the sort of non-thread safe one. That kind of arc ref cell kind of combo is a sort of standard pattern in Rust for kind of having shared mutable access to stuff. We kind of need that because we want to be able to kind of pull this kind of stuff out of the state and mess with it while also doing things with the state itself. So you'll see what I mean by that in a sec when we kind of get to looking at how the name Scratchpad works and how status bar works. I won't go through all the docs here. There's some really good kind of YouTube videos online that kind of go through how arc and ref cell and this kind of shared mutable state kind of stuff works with Rust. I'll put links to those down below. For now, the only thing you need to sort of keep in mind is while this type signature looks a little bit intimidating if you've not done Rust before or you've not used shared mutable state stuff before, we're going to be able to ignore pretty much all of it and just work with it in a reasonably simple way. For that to work, we're going to need to specify some types. So in a lot of the stuff we've done in our main RS so far, we've kind of inferred the types. It's quite nice. You can just kind of let the compiler work out what type you're working with. Here we're going to need to specify them. That's kind of how this extension stuff works. And I'll show you a nice way of doing that, which has got a great name. It's called the turbofish. Why it's called a turbofish, you can kind of see it looks a bit like a fish, but the fact that that's the sort of accepted name for it, I just find fantastic. Yeah, let's have a look at it. Let's write some code. That's going to be easier than trying to just look at the docs or just going to go through stuff. And I think if the code we end up with out of this is sort of tidy up a bit, I'll probably add that into the docs as some examples for how this stuff works. So yeah, let's have a look at that. So what we're going to do is make an examples directory. And this is something that Cargo, the kind of build tool for Rust, understands. So if we go into examples and we put a file in here, then we can run that as an example file. Similar to the kind of way that you can just run your main RS directly. We've been compiling our main RS and then running it on login, but for a normal Rust program, you can just do kind of cargo run and run your program directly after you compiled it. An example, you can kind of do the same thing, but you can't kind of, it's not for kind of building and using that as your main program. It's, as it sounds, it's an example of how stuff works, but you can have multiple ones of those. We've got this in the main Penrose repo. With the examples directory here, and each of these are sort of example window managers that you could run. We're not going to write a window manager just now. We're going to write, oh, my internet is so slow. That's painful. Come on. There we go. Yeah, these are example window managers. You could run them, and we started with that minimal one, if you remember back in episode 1. What we're going to do this time is state extensions.rs. We're just going to write a little file that we're just going to run kind of like a script, just to kind of show how this stuff works. So we'll see how we go. So demo of how state extensions work in Penrose. Cool. So we need to pull in a couple of things for this to work, and then we'll be able to start writing some example code. And we're just going to do a couple of different things, print stuff out to the terminal, and we'll get that running, and we'll see how we go. Now, one thing that I tend to find with Rust Analyzer is that it gets a little bit sad when I first start working on an example file, and I never know if I'm doing something wrong with that, or if that's just a thing that everyone hits. So what we're actually going to do is just do hello world and run that and see if that satisfies Rust Analyzer, so it's less sad. Come on. State extensions. Cool. So this is how we're going to run our example. We'll just do cargo run -- example equals, and then name of our file, but without the .rs extension. So if we run that, it's going to complain that we're not using those two things I've imported, but we hit that, we run, we get hello world, so it's picked up and it knows about that file. And we'll see if Rust Analyzer is then happy or sad. Are you happy? Are you sad? How are you feeling, Rust Analyzer? Can you tell me about the window manager? Not yet, you can't. Okay, well, we'll see. So once it starts highlighting those bits on line 2 in yellow, we kind of know, hey, there we go. We kind of know it's paying attention because now it's saying, hey, you're not using the window manager. Still won't let me do hover text though. Yeah, I never understand with examples. They seem to behave a bit weirdly with my editor setup. I'll have to have a look. Okay, so first things first, we need some state so we can put a state extension in our state. Now, oh, there we go. It's just being a bit slow. Now, the main thing around this is I don't actually give you a way to construct state on your own. The main reason for this is the state for the window manager needs to kind of be something that the window manager sets up initially and can have a bunch of understanding about how that's been set up and provisioned for when the window manager has been created, and then we can do that kind of diff process from then on. If you just kind of created your own state and dropped that in, there's a lot of things that could kind of mess up. So you need to kind of pop it off of a window manager. But luckily enough, we can make a window manager pretty simply, and we don't really need all that much. So we're just going to do that was definitely not a thing I asked you to import. Rust Analyzer, go away. We can use default for pretty much everything. So we need the config, we will have default config. We need key bindings, we will have default key bindings. We need mouse bindings, we will have default mouse bindings. And then the last bit is we need a rustcon, an X connection. So we need something that satisfies the X connection trait. Let's just make an actual Rust connection and pop that in there. Now, is it? I think it's try new, or is it just new? It is just new. Yeah. Okay. So that's our window manager. We've made it mutable because we're going to need to start messing around with this when we add state extensions, which is what we're going to do next. So adding a state extension is really pretty simple. There's two ways of doing it. If you've got access to the window manager itself, the window manager has a method that will kind of plump the state extension through into the mutable state for you. But once your window manager is running, if you've got access to the state, you can add extra state extensions while the window manager is running as well. Now, the main reason for letting you do it through the window manager is, like we'll see when we look at the status bar and name scratchpad stuff, this is the kind of way that is kind of simplest to kind of get this stuff set up, is you put your extensions into the window manager before you start it running, and then you start it running. But if you need to kind of add and remove state extensions while the window manager is running, that's possible. But the simplest thing to do is to do it at the window manager level. So we're going to do WM for our window manager, and thank you, Rust Analyzer, add extension. So like it says here, we're going to add a typed state extension to this window manager. Now, under the hood, this is something that uses a crate called AnyMap. Now, you can think of this like a hash map, but the keys are not something that you specify. So normally if you specify a hash map, you'd do something like a hash map of string to string, for example. So you have string keys, you have string values, it's kind of like JSON, and if you give a key, you can get back the value. For an any map, and there's other crates that do this and other things in other languages where it kind of gets called a type map sometimes. The key is the type that you're asking for. So when you add a state extension, you can literally put any type you want in here. So we could just put in kind of a string. So we can just say a stir as a state extension. And that works. You can put anything you want in here. We could also add a string as a state extension. But we need to call toString on that. And what you're going to end up with for this is you're going to end up with, when you ask for the state extension back, you ask for it by type. And so you can only have one state extension for a particular type at a time. If you added a state extension for stir again, for example, you'd overwrite the one that was already there. This whole approach, this whole idea is something that I've kind of pinched from the web servers that I write for my day job. It's kind of a common thing in frameworks like Axum, which is what I use, where you can kind of have server level state, and then in request handlers you can ask for a copy of that state so you can do stuff with it. It's exactly the same idea here. So if you've worked with Axum or Tide or Warp or Actix, stuff like that, this kind of idea of asking for your sort of state by type is a thing that you've probably seen before. You might not have known exactly what's happening under the hood, but this is kind of the same kind of idea. But yeah, so we can add multiple different things in. This one's a stir, this one's a string, and so we can then pop that back out and have a look at it. So at the moment we're not really doing anything to change this, but let's just have a look. So if we look at the stir, now this is going to be a static stir because we've just defined it in the code. We can then say WM, and now to get at it, now we've put it inside, we need to go down into the state. So we'll do state, there's that extension method that we said we were going to have a look at. And the problem is that that method doesn't take any arguments. If you look, it just says and self. So we just need a reference to the state, and it's not mutable reference to the state, so you can get at your extensions without needing mutable access to the state. And this is the point of the arc ref cells kind of stuff, is it lets you kind of have a look at that state even if you don't have mutable access to the state as a whole. As we'll see in a sec, you're able to mutate the state extension independently of that. Now, this is where the E bit comes in. So this is generic over E, where E is nothing. So what we need to actually do is tell Rust what type we want out of the map. And for that, we're going to use that turbofish syntax. So static stir. And so this is how it works. You do : angle brackets, and you put the type in here. So this is turbofish. And I think if you have a look, if you do it like that without anything inside, it kind of looks like a fish, I think is the argument. Sure. There's a good fun, I think there's a website called Turbofish, and I forget the extension. I'll find it. But as you saw earlier, my connection is terrible at the moment. But I'll find it, I'll put it in. It's a very satisfying website with lots of turbofish floating around and swimming. Kind of an aquarium kind of a deal. It's nice. But yeah, so here we can say, go give me that static string. And we can pop it out of the map. Now we can have a look at what that looks like. And have a look at what happens. So what we should do is print out that state extension now. Once we compile. Because as you remember, Rust is slow at compiling. There we go. So yeah, we've got our static string. That was the prefix that we put. We said this was our static string. And we're debug printing the result of calling state.extension. And we've provided our type. And if you have a look back, we get back this result ref cell. And inside the value that we have inside of there is a stir as a state extension. There we go. So this is what we were saying with the type that comes back. It's a result arc ref cell. Now arc, it is in there. It's there's not really a kind of debug printing representation of the arc, so you don't see it when you print it out. It's just a kind of wrapper that's kind of doing some kind of reference counting. But we can kind of have a look inside of that, and we can kind of get out that value. And we're doing that by type. So if you have a look, we didn't provide any arguments, like any values to the extension method. We didn't like have to pass like an enum or anything like that. It's literally just the type. So we've got static string here. We could do the same thing with our string. So if we ask for a string, and then inside of our turbofish, we specify string this time, then when we run, we should get 2 lines of output. And the first one is going to be a static string, which is our OK ref cell value, a stir as a state extension. And the second one, we've got OK ref cell value, S string as a state extension. I can't type apparently. That should be an A, not S. There we go. But yeah, we can get back those different types. And because one's a static string and one's a heap allocated string, the types are different and the map keys them differently, and we can get the 2 different values out. Now, the thing you might wonder about this is, what if I try and get like an I64? So 64-bit integer out. What happens? Well, we've not stored a 64-bit integer, and this is why this method returns a result, because what you'll get is an error saying unknown state extension. Now, the type ID stuff, I'm providing that back because I've got access to it, and if you have something you could do with that type ID, you can go and do something. But for the most part, that's mainly there for kind of debugging purposes and kind of just, it's possible to return it, so fine. But that error unknown state extension is literally just telling you, you asked in this line of code for an I64 out of the state extensions, and there isn't one. But if we add that, if we add kind of 42 as I64, and then try, then we should get back 42, because this time we've added it in. Cool, we get back 42. Now, so far, that's a static string, a heap allocated string, a 64-bit integer. It's not the most helpful state to be storing. We're not really doing anything with it. So rather than put in an I64, let's make our own struct and store that. This is kind of the idea behind state extensions, is you want to say, I want to store something. So maybe we just want a number. We just want our I64, or let's do a usize. We're going to derive something called debug. And this is what lets us do that kind of debug printing. So we can kind of show this stuff out. We can make a struct. It can be any type we want. And then let's store an instance of our struct inside of the state. So if we do add extension, and actually just to show you, there's also add extension on the state itself. So if you've got the state rather than the window manager, you can add it directly to the state if you want to. So we can add our state extension in, and then we'll do the same thing as we've done before. This one is going to be my extension. And this time, we're going to pop out the extension. And so this is a struct we've just defined. It didn't exist before we wrote this program. It's complaining we're not using n yet, but we'll have a look in a sec. But that's a brand new type. It's not a thing that Penrose has to know about in the library level. Any really does mean any. You can put any type you want in here. So we've defined our new struct. We can pop that in, and we can get at it. Now, referencing that stuff is useful, but if this was just going to be static data that we weren't changing, you might as well just have a constant in your program and reference that constant in your key bindings and hooks and whatever other extra code you're adding to your window manager. There's not really any need to have this kind of store it in the state and get it back out of the state with the type map and all that kind of stuff. That's kind of faffing around, and you don't really need it if you're not going to be doing anything mutable where you're changing stuff. Like if you're not actually going to change anything, there's not really any point. Now, what we can do now is modify it, and we'll have a look at doing that. And that's kind of really the point of doing this, is as you're running your code, if you want to track changes to things, this is how you do it. So we're going to do this inside of a scope. The reason for this is we need to get a kind of mutable handle through that ref cell type. And we then need to make sure that we drop that mutable handle and get rid of it, because that's how the ref cell and the arc and all the kind of reference counting stuff is working. We kind of need to tell the compiler specifically, we're done with this now. We're not using it anymore. It's safe for someone else to go and modify that. But that we kind of don't get for free. You kind of need to either put it in a scope like this or explicitly drop it, or do this inside of a function, for example. Actually, yeah, let's do that. And let's do it inside of a function. That's going to be a little bit easier to kind of understand. So we're going to do fn add 1. And so this will take our state, which is going to be a reference to our... Actually, no, let's just take the window manager, because then we don't need to worry about extra types coming in, because we haven't got the state imported yet, I don't think. That's really annoying. My stylizer keeps adding imports that I really don't want. Cool. So this is going to return our anyhow result as well, because we're going to use unwrap. Or the try operator rather than unwrap, I mean, to have a look at this. So if you have a look, we've got a reference to our window manager, not a mutable reference to our window manager. So as far as the Rust type system is concerned, we're not able to modify the window manager itself. But this is what the point of all of this is about. So inside of here, we're going to grab our state extension like we had up here. Oops. Yoink. So let ext equal that. And we're going to use this question mark operator. We've kind of seen that before in several places. This is basically unwrapping this result. So if we unwrap that result and it was an error, we're going to error straight away. So we're going to grab our extension. And then the next bit we need to do is we need to get mutable access to this. So at the moment, our extension is that arc ref cell thing. And if we want to kind of play around with the inside of it, we need to borrow it and then make do whatever kind of changes we want. So we're going to call borrow mut. And then once we've borrowed it, we can access what's inside of it. So our state extension has got a field called n, so we can do n, and we can do plus equals 1. Cool. Now, what's wrong with you? Oh, you're a window manager generic over the Rust column, aren't you? There we go. Cool. So now we've got our add 1. So we're going to add our state extension. We're going to have a look at it, and then we're going to say add 1 to our window manager, and then let's print out the result again after that. Cool. So as long as I've not messed anything up, we now shouldn't have that complaint that we're not using n, because we are now using n. And if you have a look, there we go. Our state extension did have a value of 42. Now it's got a value of 43. Now, we've added 1 to a number. Yay, go us. That's probably not super impressive from a programming point of view. That's probably one of the first programs you ever wrote, other than Hello World, was adding some numbers together. But the important thing here is this type signature here. We didn't need a mutable reference to the window manager to do that. We didn't need a mutable reference to the state to do that. We could grab the extension out of the state, and it gives us this arc ref cell, and then we can then borrow that and do things with it, even though we don't have the ability to modify the state itself. This turns out to be really, really important when you're writing things like the status bar and scratch pads and anything where you want to kind of modify and mess around with your state while also having a look at and doing things with your window manager. Like if you want to move windows around or change things between workspaces, you need to mutate the window manager state. And you need to call methods that require mutable access to the window manager state. But if you need to kind of hang on to your state as well at the same time, you've got to kind of thread everything through all together. and you very quickly end up tying yourself in knots. So this is the whole point of the state extension stuff in Penrose. It gives you that kind of escape hatch so that you can modify things as you go. Now, I don't think there's too much more that we'll cover right at the moment, other than... Yeah, let's have a look. There's a couple of... Actually, no. There's a couple more things that we want to have a look at. Just quickly. So there's this. There's extension or default. So if your type implements default, so there's a sensible default value for it, then this is a way of making sure that you always get a value back. So if you have a look, this one doesn't return a result. It won't ever with unknown state extension. Because if it is an unknown state extension, it gives you the default value instead. So we can have a look at that. We just do that the same way here, where we could say extension or default. And what should we put in for this one? Let's put in... let's just put in a Boolean. So if we ask for a Boolean, we've not stored a Boolean in the state extensions. But if we run that, you'll see that this time we get a value back. So the default value for a Boolean is false, so we get a ref cell value false. This is kind of useful if, mainly if you're doing something where you are going to be adding a state extension in at runtime, like while your window manager is in operation, and it just kind of abstracts that pattern where you might say, check to see if I've added it yet, and if I've not set the default value, then I can go do something. It's just doing that. So it just lets you kind of leverage that and write kind of a few less lines of code. And then the last one that is there as a helper, which I don't really use myself in anything that I've written, but it is useful and it's kind of part of the standard kind of map APIs in Rust, is the ability to remove something from the map. So if you really need to, you can remove a state extension from the map. And you can sort of completely take that out. You'll then, at that point, you'll just have the value. It won't be wrapped in this arc ref cell stuff. You'll just get your value back. And then, pardon me, at that point, you can do whatever you want with it. But nothing else will be able to get it back out of the map unless you go and restore it. So let's just quickly to kind of show that. We had that... we have that Boolean, I suppose. So, well, no, let's do it with our let's do extension or default with our I64 that we had before. Or no, let's just add extension, I suppose. Let's add an extension of 42 as I64. Oh no, sorry, add extension is what I want, isn't it? So we can add in a state extension, and then I can have a look at our removed extension. And if I do wm.state remove extension, and the type we're going to remove is I64. That should be fine. Cool. And this time around, you'll see that what we get is sum 42. So it's not the ref cell, it's not wrapped in results, it's giving us just the value, but it's wrapped in an option. Now, the reason it's wrapped in an option is if we did this with something that wasn't in there, so if I removed an I32, so a 32-bit integer instead of a 64-bit integer, we've not actually put an I32 into state, so this time we'll get back none, because there was nothing for us to remove. And again, this is kind of just mirroring the standard library map APIs, where you can ask to remove a key value pair. If the key is in there, you get it back. If it's not in there, you just get none. Like, you don't get an error like that unknown state extension stuff. the sort of purpose of that error as an unknown state extension is mainly just that you're normally doing this kind of stuff in functions where you're working with results. So being able to use the try operator directly on that, an error if you've not set up your state properly, is a little bit nicer than having to check the option and explicitly error yourself if it wasn't there and all that kind of stuff. Cool. Okay. So that's kind of how state extensions work. You add them in just however you want. You just call add extension and you can put literally whatever you want in there. There are currently no restrictions on what you can put in there. And then you get it back by asking for that extension and specifying the type. So when you get it back, you need to say, hey, this is the type that I want. Now, the reason we're doing the turbofish stuff here, like we said before, is the type of what we get back is this result arc ref cell stuff. So if you wanted to take that static string out, you'd have to specify what that type was. And that type is actually a result arc ref cell static stir. 3 of those, I think. So you can do that. That would work. And at that point, you wouldn't need the turbofish. You could just say wm.state.extension that. I find it a lot easier to use the turbofish. You just specify the type that you want there, and you don't need to worry about result arc ref cell. Also means you don't need to import arc and ref cell, so you can specify the type. You just provide the type that you're working with, and you're kind of done. And so that is a little bit nicer to work with. But yeah, that's kind of the idea behind it. You can put whatever you want into state. You can pull it back out, and you don't need a mutable access to the window manager or state to be able to then modify that stuff that's inside. And this gives you that little bit of leeway, that escape hatch, so that you can mess around with your own state independently of the window manager state, even though we're storing it inside of the window manager state. If all of that sounds so super cryptic to you, don't worry about it. It's plumbing stuff that means that you don't get horrifying lifetime errors in your Rust code when you try to write a window manager. That's the best way to think about this if you don't care about any of the stuff that I've just been waffling about for the last 37 minutes. But to kind of look at this stuff in practice, let's add a named scratchpad, because I really want a named scratchpad. I like having my pop-up terminals. So let's do that, and we'll see how this works. So we're going to pull in some other extensions now. So let's go back to the docs and double check where this stuff lives. I think I've got a tab for it. Yeah, cool. So Penrose extensions hooks named scratchpads is where this stuff lives. And we need add named scratchpads and the named scratchpad struct is the two things we need. So extensions, hooks, named scratchpads. Is it plural? I think it's plural. Yeah. And this is going to be named scratchpad and add named scratchpads plural. Ooh, Rust Analyzer is still waking up. Come on, Rust Analyzer, you can do it. So hopefully that'll wake up in a sec. And if you have a look at the docs on add named scratchpads, I think I have an example in here. If I don't, we'll have to add one and see how we go. Oh, that's very bright. We don't. Never mind. Okay. But if you have a look, we pass in the window manager and a vec of these named scratchpads, and what we get back is the window manager. Now, what this is doing under the hood is calling that state, that add extension method for you. It's kind of popping the scratchpads in as a state extension. So we'll come down here, and where should we pop this? We've got our hooks being added into the config. We've got our status bar. We've got our window manager down there. Let's set this up after our hooks. Why not? So there's two things that come back from this when we create a named scratchpad. Oop, my fan stopped going crazy. So is this now working? No, Rust Analyzer is really quite sad at the moment. Oh, Rust Analyzer, you can do it. So when you make a name scratchpad, there's a couple things we need to pass in. And what you get back is the name scratchpad and this kind of toggle handle. So this is the thing that acts like the key binding for toggling. So we need to specify the name for it. That's the kind of name bit in the name scratchpad. The program that we want to run, and the query that we want to use for identifying that name scratchpad. So we had a look at this in the manage hooks, where we said that we had a class name of Qt browser. It's the same kind of query stuff that we're talking about just now. So I think we're going to set a custom class name on our terminal, and that will let us go and find it. And then we have a manage hook of what we want to do when we have that. I like to do a kind of float-centered kind of one, so we'll do that. And run hook on toggle is basically each time you toggle with the key binding, should you make that hook rerun? So we'll have a look at doing that as well. And is Rust Analyzer ever going to wake up? Or do I need to kill this session? I think I need to kill this session. That's a bit sad. Come on. Why are you upset, Rust Analyzer? Let's see if you can wake up. Because otherwise all my formatting is going to be off, which is a bit annoying. So let's have our name scratchpad and our toggle scratch. And that's going to be name scratchpad new. And we need to pass the name of the scratchpad first. The name of the scratchpad is going to be terminal. We need the program that we want to run. You might have noticed my terminal's a bit different. I've swapped over to using Kitty on my ThinkPad, which is what I use at work. Just because I was having a few issues with ST behaving weirdly for a couple of things, and I thought I'd just be consistent and use one terminal across both systems, so why not? So we're going to use Kitty, and Kitty has a class name flag, and we're going to have Kitty scratch. That's quite fun. Hadn't thought that through until I typed it. That's delightful. Cool. And we want our class name is what we're going to match on, which is Kitty Scratch, which I'm now all for. That's fantastic. And our hook is going to be a floating one. So if we click on Manage Hook, and if my internet will actually load, then we'll come down to implementers, and we want floating centered. What we want. So that's extension hooks manage floating centered. So why are you unhappy? Ooh. What have I done wrong there? Oh, I've missed the P. There we go. Name scratchpad, capital P. Cool. There we go. And we want manage hook, and we want floating centered. There we go. Cool. Name scratchpad. You need a capital P. And this is going to be floating centered. And how do we construct a floating centered again? New, and we've got width and height. New, and we'll do, what do I normally do? I think I normally do 0.8. 0.8. Let's try that. And we then need to say if we want the toggle to run each time or the hook to run each time we toggle, and we do. Oh, what's this? Okay. And then this is what we said way in episode 1, I think. We're getting that error again where it's like, I don't know what X is. That's because we've not added it in yet. So if we come down to our... oh, no. Okay. So we will need to do this up here. Yeah, we'll need to do this up here because we need to pass the toggle in when we set our key bindings, otherwise we won't have a key binding for this. But then if we do bar, add to, and we're going to do add name scratchpads. Actually, let's not all stack this up. Let's do it separately. So that's our WM, and we're going to say let WM equal add name scratchpads, and we just put in our window manager and a vec of our name scratchpad. And that's fine. And then that should get rid of our error around not knowing what X is, but we need to put through our toggle scratch up here so we can actually have a key binding for it. So let's do that. And this actually will need another type for. So this is toggle name scratchpad. That's the key handler that we end up with for doing this. And I like to bind that to mod slash. And in here, we just put in toggle scratch. And that should be usable as a handler. Oh, what's wrong? Does that need to be in a box? It does need to be in a box. Okay. Box new. Cool. Okie doke. So if we've got that all set up, is anything shouting and screaming at us? The state engine stuff is a bit unhappy. Why are you unhappy? Oh, okay. So our test is now going to be unhappy because we don't have that toggle anymore. Okay, so we can fix that if we just build this down in our test as well, just so that our test is a bit happier. Let's do that. And we put the toggle scratch in there. Okay. Anything else? Cannot infer. Oh, okay. Now this is going to be unhappy because we don't know the right X. Oh, that's annoying. So specify the generic on the struct. That's true. So if we go to new, does new on name scratchpad? Does that have a X in it? Where's the X coming in? Can we specify it like this? Can I say name scratchpad? Like that. Yeah, cool. A little bit ugly, but never mind. We don't actually need the name scratchpad, so we can get rid of that. We just need that toggle handle so we can drop it in. Okay, so yeah, that's one thing that sometimes happens with test code bits is you end up with a little bit of extra kind of setup so that you can kind of satisfy the stuff that you need for your API when you're testing it. That's a little bit unfortunate. I'm not sure if we really want to rewrite raw key bindings to not have the toggle scratch. It's a lot nicer to have the key bindings kind of built separately, and especially as we start adding more and more things in there, it'll be nice to handle that as a function off to one side. So I think we will leave it like that, but it's a little bit unfortunate that we then need to pass through that toggle name scratchpad to get that to work. Oh well, that's not too bad. And I think this is going to complain about the, oh, okay, I can do 42_I64. Okay, actually, yeah, let's do that. Rather than doing as I64, we can kind of, there's a sort of special syntax in Rust for specifying those things with a suffix, so let's do that. And then at least it won't shout at us when we try and compile. Okay, so now if we do make build, we'll do our debug one so it's a bit faster. We should have a name scratchpad that we can toggle and pop up, which would be nice. Let's have a look at that. Ooh, that's slow, even though it's the debug build. Come on. There we go. And installed. Cool. So now if we restart, we completely freak out. What's going on? Why is everything dead? So something is not happy. Unknown key name. Ooh, okay. Right. That's a perfect example of why we have the tests and why I should have run them. if I do cargo test, I think what we're going to see is that our key bindings are now invalid. And I suspect that we are frantically spinning, restarting everything. Yeah. Panic that slash is not a known key name. Cool. Great. Well, you know, these things happen. Like we said, we're writing software, things will break, especially if we don't run the test suite. This is why we have test suites, and exactly why that's there. So, how are we going to fix that? If I go to my personal window manager, and I look at how I've got this set up, what is it? Is it just /? Is it slash? It's slash is what I should have. M dash slash. Yeah, dash slash. Okay. Right. Well, okay. This is why we have those tests, and shame on me for not actually running those tests. Okay, so this time, does that work? That should work. Okay. So now if we install and restart, we should be okay. And I think just the act of installing this should make it work, because I think we're in the restart loop frantically because it keeps dying every time. So there we go. Hey, and it comes back. Because the moment the right thing was there, it actually worked. Cool. Okay. So now if I do mod slash, nothing happens. Did I get the flag wrong for Kitty? It is dash dash. Oh, it's dash dash class. Damn it. Okay. Should have checked that as well. Okay, so this should be dash dash class. This is why there's documentation, everyone. And this is what we should be doing, is reading the docs and running the tests. Do as I say, not as I do, pretty much. Right, okay, restart that. Now, if we do mod slash, we get a pop-up terminal. Yay, cool. So now we can open and close a pop-up terminal to our heart's content, which is great because I really like using that for doing things. So my general workflow is to have editor open and let's make the text bigger on that, and then be able to do the cargo test or cargo build or whatever it is from a pop-up one, because then that means I can kind of jump between the test output and my editor quite nicely, which is kind of good. And also I can go and hide it away and all that kind of stuff, which is cool. Great, okay. So that was a little bit more clunky than we would have liked, but never mind, that kind of happens. That's also kind of a good demonstration of what will happen while you write your own window manager. You will occasionally realize that you've completely knackered the thing and you need to get debugging, at which point having some tests that you can run is very helpful, because that can then show us what is going on. Tell you what, let's make that one correct as well. I'm not actually using it, but yeah, let's make sure that actually is the correct flag for Kitty. Cool, okay. So that's adding those state extensions in. If we have a look at that add name scratch pads, I don't know if Rust Analyzer is awake or not. It's not. Let's see, I'll go navigate there myself. So source extensions, hooks, name scratch pads. Now, this function that we're calling, add name scratch pads, if you have a look, it takes in the window manager, it makes sure the window manager is mutable, it gets its scratch pads, and it builds some state. So it's making a hash map of the name you've got for your scratch pad to the actual scratch pad struct itself. And the reason for this is you can add multiple name scratch pads in, but you need to kind of add them as a bulk operation, and we sort of store the state in one place. And to make sure that no one else messes with that state extension, because if you think back to what we were doing with the example, we could, so long as we knew the type, we could go grab that state extension. So anyone can go and grab a string out of the state extensions. Anyone can go grab an I64 or a bool. But you can only grab my extension if you can specify the type. So if you can specify my extension, then that works fine. Now this struct is not public, which means that outside of this file, nothing else can reference that type. And that's what we're doing here as well for the name Scratchpad. There is a wrapper, all this is a wrapper around the hash map. We could just put in the hash map, but if we put in the hash map as the state extension, anyone could specify that hash map type and pull the state out and do things with it. If we wrap that in our own type, a named Scratchpad state, then when we are working with it, when we go and get our state extension, when we go grab named Scratchpad state, this file is the only piece of code that can get at that type, because the type lives in this file, it's not public. So inside of this file, we can work with the named Scratchpad state. Outside of this file, we know, because the compiler will enforce it, no one can touch that state. This turns out to be very helpful. There was actually a subtle and really hard to track down bug with the named Scratchpad stuff that one of the people who's in the Penrose Discord server was giving me a hand with, trying some things out and being very, very kind and giving me some logs to kind of sift through. And the fact that I can say categorically that the bug has to be in this file, it's not anywhere else, massively helpful for being able to work out what was going wrong with this. But if you have a look at what we're doing inside of add name scratchpads, it's exactly what we were doing in our example. We build our state. In our example, we just made the struct. It was pretty simple. But then we add it into the state extensions. And then we're also setting some hooks. That's the stuff that we had a look at last episode. And then inside of the hooks, this is how the hooks get at that shared state. So the hooks need to know about the scratchpads they should be working with. So at the start of each hook, they key into the state extensions and pop out the named scratchpad state and go and have a look at it. Same thing for the event hook. We key in there and we go and grab the named scratchpad state. And also same thing for the key event handler from that toggle named scratchpad, that thing that we just added into the key map. There we grab the state extension, and that's so that we can have a look at it and mess around with those properties that we've stored inside of the state as well. So this is a kind of real, actual state extension that's really doing things. All we're really tracking with this is storing those pieces that we specified when we made the state extension. So the hook and the query that we need to run and the program we need to spawn. We're basically just storing parameters for function calls later on, essentially, and then running that code later when we need to. The same kind of thing happens with the status bar, but there's a lot more to it. So I think rather than keep going, because this video is nearly an hour now, we'll have a look at the status bar as a whole video, because there's a bunch of stuff we can look at with the status bar. But the kind of thing with the status bar is the status bar itself is a state extension. Like all of the widgets and the sort of status bar state and the ownership of like drawing the status bar live as a state extension inside of your window manager. And so that's how that kind of works. So I think we'll wrap this one up here. We've got reasonably far with all this stuff. We've added our scratchpads in, which is nice. It's always nice to be able to kind of have some sort of easy to get to sort of man pages or test output or whatever it is. It's going to be useful for stuff we do going forward. But the main thing I suppose we've done is have a look at this example and what is going on with state extensions. Hopefully this has been helpful. You probably won't find yourself doing a huge amount with state extensions unless you're writing like really custom behavior for Penrose. And if you are doing that, I'd really like it if you found something really cool that you thought Penrose was missing. Or a lot of what I'm doing is going through xmonad contrib at the moment and finding things from xmonad that look cool and adding those in. That's where the kind of named scratchpad stuff came from, to be honest. So if you fancy a crack at any of that, or if you get something implemented that you think's cool and other users of Penrose might find interesting, let me know. Come have a chat. if we can get it set up and sort of generically usable and make sure that it's sort of safe to run and not going to crash anyone's window manager, stuff like that, so no unwraps and bits and pieces, then we can have a look at adding it into the Penrose crate and making it part of Penrose. So if that sounds interesting to you, if that's a thing you would like working on, or if you too want to go and sift through Xmonad contrib and add stuff, please reach out either in the Discord or raise a GitHub issue and have a chat, and we can see. But for now, I think we'll wrap up, and next time we'll do a bit of a deep dive into how the status bar works, which is itself a state extension. So until next time, happy hacking on your window manager, I suppose. Bye.